Hi, in this tutorial we have an exercise related to chair conformations of cyclohexane. The question in the exercise asks us, draw the most stable chair conformation of each of the following compounds on the templates. Let's look at the first option. It is cis 1-isopropyl 3-methyl cyclohexane. Let's draw this molecule on the chair template. Let's start numbering carbon atoms on the chair cyclohexane. I start from here as number 1, but you can start on any carbon. It doesn't change the answer. 1, 2, and 3. We know that on each carbon we have an axial position and an equatorial position. For the first carbon, the axial position is facing upward and the equatorial position facing downward. On the third carbon is also the same case. The axial position is facing upward and the equatorial position is facing downward. So in order to have a cis isomer, both substituent isopropyl on the first one and methyl on the third one should be facing either upward direction or downward direction. And we know that when the substituents occupy equatorial positions, they are more stable than if they occupy axial position. So for that reason, I'm going to place both isopropyl and methyl on the equatorial position since they are all facing both downward and it will be a cis isomer. So I'm placing isopropyl here on the equatorial position and methyl is on the equatorial position of the third carbon, and I'm going to erase this other drawing. So these positions, axial positions, are occupied by hydrogen, so I'm not showing. So this is the most stable chair conformer of 1-isopropyl 3-methyl cyclohexane, and it is cis. Let's move to the second option. It says that it is trans 1-isopropyl 3-methyl cyclohexane. It's a similar molecule, but it should be a trans isomer. Again, let's label the first carbon and the third carbon, and let's place equatorial and axial positions. And we know that in the first and third carbon, axial positions are facing both upward direction and the equatorial positions are facing both downward position. Trans means that they should point opposite directions, or they should be on the opposite faces of the ring. So one should be up and the other should be down. And we know that isopropyl is bulkier than methyl. So if we have to place one of them on the axial position, it should be the methyl one. So for that reason, I'm going to place the bulky isopropyl on the first carbon on the equatorial position, and this will be hydrogen. And the methyl group should be on the opposite face, should be facing upward, so it's here, and the other should be the hydrogen. So this is the most stable one. If we do the opposite, if the isopropyl is on the axial position and the methyl in the equatorial position, the isopropyl is going to have more steric 1,3 diaxial strain with the third carbon, and also the third carbon, there's a hydrogen here, then there will be diaxial strain. So let's just clean the structure. So this will be the most stable chair conformer of trans 1. Now let's move to the option C. Option C is a little bit different from the first two options because it's not a given name, it's just a given skeletal structure, and it's not a chair structure, it's just a hexagon structure. So but we have here dash and wedge drawing styles, and what we should know from wedge and dash drawings, if two substituents are drawn as wedge or dash dash, meaning that they are occupying on the same face or they are pointing the same direction, upward or downward direction. So then let's just label the carbons here. So I'm going to label this carbon as number 1. This one will be number 2, because if we number this way, the substituent will get the lowest numbers as much as possible. So it's 1, 2, and 4 are the lowest numbers that we can give to substituent positions as. Okay, so we have on the first carbon methyl, and we have an methyl group on the second carbon, so they should be facing opposite directions because one is wedge, the other methyl is dash, and number 4 methyl is a wedge, so number 1 and 4 should be pointing the same direction, and number 2 should be pointing the opposite direction of 1 and 4. Okay, so I know that if I place substituents on the equatorial positions, they will be more stable. So for the first carbon, I'm labeling this carbon as number 1, this one 2, this is 3, this is 4, but you can do in a different way. It will give you the same answer. I'm going to place an equatorial position here and an axial position. Here, number 2, a down axial position and up equatorial position. And in number 4, we have a down axial and up equatorial. So as you see, like facing upward, downward changes depending on the position of carbon. In the first one, the axial one is facing upward, but in the second one, the axial one is facing downward. Okay. So now let's label, for example, I want to place the first methyl group as an equatorial, and this will be an axial hydrogen. In the number 2, methyls should be on the opposite faces or pointing opposite directions. So this is a down equatorial position. This is an axial up position. So 1 and 2 methyls should be facing opposite directions. So if one is facing down, the second should be facing up. So the second should be on the equatorial position. So we decided this one. Okay, let's go to number 4. The equatorial one is facing upward and the axial one is facing downward. So when I check, for example, 1 and 4, they should be facing the same direction, upward direction, because I chose the first one facing upward direction, or sorry, downward direction, and the number 4 should be also facing downward, so it should be the axial down, and this should be hydrogen. Okay, so now let's look at, do we have any axial strain? Yes, number 4 will be interacting with the number 6 axial hydrogen this way, 1,3 diaxial strain, and also there is another axial down hydrogen on the second carbon. They are interacting, but we have just one methyl interacting with these two axial. Is it the most stable one? Yes. How about the second conformer? Because like we know that cyclohexanes undergo ring flip process and axial positions move to equatorial positions move to axial positions. So for example, here I have two equatorial, this is equatorial, and one axial position. In the flip process, since equatorials will be shifting to axial positions, I will have two axial and one equatorial methyl groups, so it will have more strain in this way. So the one that we have drawn, the first, is most stable because it has less strain. So again, let's just clean the structure so that we can have just the correct answer. Okay, this is the answer. So basically, one of the methyl is in equatorial, the second one is in the equatorial, and the fourth methyl is in the axial position. This is the correct answer. Thank you so much for watching the video.